Today's lesson is all about completing the square, and this is probably a new topic for you, and it's a big one. It has all kinds of applications, different places we can use it. So we really want to feel good about this. So let me give you a quick overview. When we complete the square, we're taking some kind of quadratic that isn't a perfect square, and we make it a nice perfect square. That makes it easier to solve. It'll factor really nicely. You can do square roots of both sides, things like that. So let's say we've got a general quadratic x squared plus bx, all right? Hey, that's not a perfect square, of course, but if we added the right number to it, it will become a perfect square. A couple examples. X squared plus 6x. If you add 9 to it, you would get x squared plus 6x plus 9, which factors to x plus 3 quantity squared. Nice, perfect square. X squared plus 10x. If you add 25 to it, you would get x squared plus 10x plus 25, a nice, perfect square. Okay, so the key, excuse me, let's look at some examples. Let's add the number. How are we doing that? What number do we know to add? Well, this middle number is where we look, all right? You divide it in half and square it. So half of 18 is 9. Squared is 81. So if you look at this guy, two numbers that multiply to make 81 that also add to make 18, 9 and 9. So this would be factored as x plus 9 quantity squared. Nice, perfect square. How about this one? Half of this and squared. So half of 14 is 7. Squared is going to be 49. Can you see what this will be? X plus 7 squared. What if we throw a minus in? No worries. Half of this is 6 squared, 36. The only difference, because the minus is here, it's going to be a minus 6 here. Can you see where this 9, 7, and 6 are coming from? 9 to square root of 81. 7, square root of 49. 6, square root of 36. Now the sign here also has to go with it, right? How about this one? Half of 2 is 1 squared is still 1. So you just add a 1 here, and this is x minus 1, quantity squared. So that's just a little taste. What number do we add to complete the square? Let's apply that to solving problems. Solve by completing the square. So first of all, let's get it kind of into that format. I'm going to add this 12 over. So x squared plus 6x plus something equals 12. Well, what could go in the box here? Think about what we just did. Half of 6 is 3, squared is 9. Now, we're solving an equation. You have to do it to both sides. I can't just add 9 to one side. That would totally change it. So this will now factor to a nice perfect square. X plus 3 squared equals 21. Take the square root of both sides. That's one reason this is so powerful, because square root makes it easy to get rid of that square. So we now have x plus 3 equals plus or minus square root of 21. 21 won't simplify, so let's just leave it and then subtract 3 over. X equals negative 3 plus or minus square root of 21. And that looks like our solutions, okay? How about this one? Very similar. Let's subtract that 34 over. So x squared plus 6x plus something I should have done a different middle number, but that's okay. It works the same. Equals negative 34. Hey, we know it's a 9 there, right? So plus 9 to both sides. X plus 3 squared. Oh, negative 25, right? Square root both sides. Get plus or minus there. X plus 3 equals plus or minus 5i. Oh, that negative under the radical. So we've got imaginary. And then subtract that 3. So negative 3 plus or minus 5i. Completing the square, powerful tool to solve quadratics. Here's another application. Write in vertex form and state the vertex. So remember we had quadratics. We did this in a previous lesson. Ax squared plus bx plus c, that's general form, but we also have this form, ax minus h squared plus k. Really nice because the vertex is built right in. Well, we did this before, and the way we did it, we did x equals negative b over 2a. Sorry, that was kind of sloppy. We found out this x value, or the h value, and then we plugged it in to get the k, and we could just rewrite this. Well, here's another tool, another way. You could complete the square on it, okay? So instead of solving, though, I'm going to go y equals, let me do it like this, x squared minus 4x plus something. I'm just going to scoot that negative 1 over, all right? So let's complete the square on this. Half of 4 is 2 squared is 4. Now watch what I do here. If we were solving, I would subtract 4 from the other, or I'd add 4 to the other side, right? But I'm actually just working on the same side, so I'm going to subtract 4. Now look what I just did. Added 4, subtracted 4, I just added 0 to this equation. That would be the same as adding 4 to this side and then bringing it over. Okay, now let's just clean it up. So this nice perfect square now factors to x minus 2 squared, negative 1 minus 4, negative 5. Hey, just like that, we wrote this in vertex form. Isn't that nicer than doing negative b over 2a, plugging it in, getting the y value? I think it is. Okay, very powerful. How about this? We've got a number out front. Okay, let me show you how we handle that. I'm going to factor that 2 out of this guy. So that 2 is still going to be in front. It is our a. But that gives me x squared minus 2x plus something. And again, just scoot that 5 over. Notice I only factored the 2 out of these two guys right here. Now what goes in my box? Half of 2 squared is 1, or half of 2 is 1, squared is still 1. Now here's where it's just a little different. I didn't just add 1, I added 2 times 1, which is 2. So I need to subtract 2 out here. So I just added 2, I subtract 2 to keep it the same. Y equals 2, x minus 1 squared plus 3. Look at that. Just like that, I wrote that in vertex form. So again, completing the square is awesome. Very, very powerful tool. All kinds of applications. So really, go through this, take good notes, work things out. This is a big one we want to feel really good about.